everyone, hope you all are doing well. In this video, you will be learning from chapter 2 and 3 acids, bases and salts. Let's get into the video. The contents are 1. What are acids, its composition and examples? 2. What are bases, its composition and examples? 3. Properties of acids and bases. 4. What are H plus and OH minus ion concentration? 5. What is pH scale and pH in everyday life? 6. What are salts, their properties and uses? 7. Water of crystallization. What are acids? Acids are chemical substances that have properties like they are sour to taste and corrosive to touch. Examples of acids we come across every day are lemon juice, which has citric acid in it, and tamarind juice, which has tartaric acid in it. What are indicators? Indicators are chemical substances that change color when acids or bases are added to them. Examples of indicators are blue and red litmus, methyl orange, and phenolphthalein. Acids have the following effects on indicators. Acids turn blue litmus to red. Acids turn methyl orange to red. In acids, phenolphthalein remains colorless. Examples of acids are lemons and oranges, which have citric acid in it, vinegar, which contains 5% by mass acetic acid, pop and fertilizer, which contains phosphoric acid in it. Chemical composition of acids. So, what is the special chemical composition of all acids that make them behave in this manner? Like all of them turn blue litmus red, they are sour and corrosive. All acids contain H plus, that is hydrogen, and they release H plus ions in their aqueous solution. Acid gives H plus plus anion. Anion is a non-metal or a polyatomic ion. In the table below are few examples. For example, first one, HCl called hydrochloric acid gives H plus anion Cl minus anion name chloride. Second, H2SO4 called sulfuric acid gives 2H plus and anion SO4 2 minus anion name sulfate. Third one, HNO3 called nitric acid gives H plus anion NO3 minus anion name nitrate. Fourth, H3PO4 called phosphoric acid gives 3H plus ions anion PO4 3 minus anion name phosphate. In all the acids, they release H plus ions in their aqueous solution. What are bases? Bases are chemical substances that have properties like they are soapy to touch and taste bitter. Examples of bases we come across every day are soap, baking soda, etc. Bases affect indicators. Bases turn methyl orange to yellow. Bases turn red litmus to blue. In bases, phenolphthalein turn colorless to pink. We will learn about pH values later, so don't look at that column. Some of the examples of bases are we come across day to day life soap, which is made of sodium hydroxide, household cleaners, ammonia, antacids, calcium hydroxide, and magnesium hydroxide. What is common in chemical composition of all bases? All bases give out OH minus ions in its aqueous solution. Base in its aqueous solution gives cation plus OH minus. Cation is a metal or polyatomic ion. Examples: NaOH gives Na plus plus OH minus in its aqueous solution. NH4OH gives NH4 plus plus OH minus in its aqueous solution. Bases soluble in water are called alkalis. Properties of acids and bases. Acids contain H plus ions in their aqueous solution. Bases contain OH minus ions in their aqueous solution. Acids taste sour, bases taste bitter and feel soapy. Acids affect indicators. Acids turn blue litmus to red. Bases turn red litmus to blue. Acids turn methyl orange to red. Bases turn methyl orange to yellow. In acids, phenolphthalein remains colorless. In bases, phenolphthalein turns colorless to pink. Acids conduct electric current. Bases also conduct electric current. These are the difference between acids and bases. H plus and OH minus concentration. We know that a water molecule is two atoms of oxygen and one hydrogen atom bonded together with covalent bonds. If we take a liter of water, most of the water molecules are like this. But a few water molecules, because the molecules are in motion and keep bumping into each other, break up as H plus and OH minus ions, and this H plus ion actually sticks to another water molecule, and this is called a hydronium ion and has an overall positive charge. How often are hydronium ions found? The concentration of hydronium ions is found to be 1 into 10 power minus 7 moles per liter of pure water. You have learned what a mole is in ninth standard, right? A mole represents a huge quantity. It is equal to 6.022 into 10 power 23. In other words, since 1 mole is 6.022 into 10 power 23, there are 6.022 into 10 power 23 into 1 into 10 power minus 7, which is equal to 6.022 into 10 power 16 hydronium ions in 1 liter of pure water. 1 liter of water is 1000 grams, which is equal to 1000 divided by 18, which is equal to 56 moles approximately. So the ratio of hydronium ions to regular water molecules in pure water is 1 divided by 56000000. So don't worry too much about these calculations. All you have to remember is that hydronium ions are found in very small quantities compared to water molecules in pure water. But when we add an acid, the number of H plus ions increases, that is, hydronium ions increase because acids donate H plus ions. In pure water, number of hydronium ions are equal to that of hydroxide ions. The balance of hydrogen ions, or rather hydronium ions and hydroxide ions, determines whether the solution is acidic or basic. When the hydrogen ions outnumber the hydroxide ions, the solution is acidic. If the reverse is true, then the solution is alkaline. What is pH? In order to determine how acidic or how alkaline a solution is, we define a quantity called pH. pH is defined as the negative logarithm of H plus ion concentration in water. pH stands for the power of hydrogen. pH is equal to minus log H plus or minus log H3O plus. Square brackets indicate the concentration in moles per liter. So the concentration of hydronium ions in pure water is found to be 1 into 10 power minus 7 moles per liter. Hence, the pH of pure water is equal to minus log 10 power minus 7 is equal to 7. When we add an acid, the number of H plus ions increases. For example, the number of hydrogen ions or hydronium ions in orange juice, which is acidic, is 10 power minus 4 moles per liter. Remember that 10 power minus 4 is a bigger quantity than 10 power minus 7, which means that it has more hydrogen ions compared to pure water. Thus, the pH of orange juice is minus log 10 power minus 4, which is equal to 4. When we compare pure water and orange juice, the acidity is more in orange. What is pH scale? A scale for measuring hydrogen ion concentration in a solution is called pH scale. The colors shown here in the pH scale are the colors an universal indicator would turn when it is added to an acid or a base. So the ranges in the pH scale 0 up to less than 7 is acidic in nature, example HCl. 7 is neutral, example water. More than 7 up to 14 basic in nature, example NaOH. These are the ranges in the pH scale. Variation of pH with the change in concentration of H plus and OH minus ions in its aqueous solution. Take pure water. The number of H plus ions is 10 power minus 7 moles per liter. So its pH is 7. Now we add an acid, and since the acid has H plus ions, the number of H plus ions increases. Now say the number of H plus ions increases to 10 power minus 6. Remember, 10 power minus 6 is greater than 10 power minus 7. So the pH has become 6. If we keep adding more acid, H plus ions are going to increase and the pH value is going to come down, like to 5 and then to 4. So remember, the lower the pH, the more acidic the solution is. A pH of 1 indicates it is a very strong acid. The same when it is opposite, it holds for bases. If to pure water we start adding a base, the OH minus concentration increases and the H plus concentration decreases. Say to minus 8, then to 10 power minus 9, and so on. The pH value increases to 8 and then to 9. Hence, a pH of 14 indicates a very strong base, and a pH of 8 indicates a mild base. pH values of common substances we come across. So, which is the strongest acid here? It is battery acid with a pH of less than 1. So, this we call it is a strongest acid. Which is a mild acid? Milk. Which is a mild base? Soap. Very good. Which is a strongest base? It is drain cleaner. Correct. Which is more acidic? Milk or coffee? Milk has a pH of 6 and coffee has a pH of 5. So, coffee is more acidic in nature. Which is more alkaline, bleach or soap? Yes, bleach. Very good. So, it is more alkaline than soap. Which has neutral pH? Fresh water and blood has neutral pH of 7. So we have different examples we come across in our day-to-day life. These are the common substances we come across. Importance of pH value in everyday life. Human blood, tears, and saliva have a pH range of 7.0 to 7.8, which is optimum for survival. For gardening and farming, the best crops are usually obtained with neutral or acidic soil, pH 6.5 to 7. Below pH 6.5, the soil is not suitable for normal growth of plants. HCl produced in the stomach is important for digestion. Hyperacidity increases in the amount of acid during indigestion, causes pain and irritation. The excess acid is neutralized by the intake of antacids. When the pH inside the mouth becomes lower than 5.5, it causes tooth decay. Toothpastes are generally basic, so they neutralize the excess acid and prevent tooth decay. Stings of insects such as ants, bees, wasps contain methanoic acid which cause pain and irritation. Use of a mild base like baking soda on the stung area gives relief. These are some of the importance of pH value in our day-to-day life. What are salts? Acids react with bases to produce salt and water. This is known as neutralization reaction. For example, the reaction of sodium hydroxide with hydrochloric acid produces a salt, that is sodium chloride, and water. Thus, a salt is an ionic compound that has a cation other than H plus and anion other than OH minus. Example, KCl, which is potassium chloride, and CuCl2, which is copper chloride. In a neutralization reaction, one H plus ion of acid is neutralized by one OH ion is base. When all the H plus ions in the acidic solution are neutralized by the same number of OH minus ions of basic solution, it is called complete neutralization. Properties of salts. 1. Salts are ionic in nature due to the presence of ions. 2. They are brittle, hard, and crystalline solids. 3. All potassium, ammonium, and sodium salts are soluble in water. 4. All salts are fairly good conductors of electricity. Some uses of salts. Sodium chloride, which is also called common salt, is used in cooking. It is used as a preservative in pickles and in curing meat and fish. It is used in the manufacture of soap. Sodium chloride is the key raw material for manufacturing other salts. Sodium hydroxide NaOH. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. The process is called the chlor-alkali process because of the products formed: chlor for chlorine and alkali for sodium hydroxide. 2 NaCl in aqueous solution plus water gives 2 NaOH plus chlorine and hydrogen. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. Some of the uses of sodium hydroxide. It is used in the making of soaps and detergents. It is used for making artificial textile fiber called rayon. It is used in making dyes and bleaches. Bleaching powder, CaOCl2. Chemical name calcium hypochlorite, also called calcium oxychloride. Chlorine is produced during the electrolysis of aqueous sodium chloride, that is called brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime, calcium hydroxide. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. Uses of bleaching powder. It is used in textile industry for bleaching cotton and linen. It is used in the industry for bleaching wood pulp. It is used to make drinking water free from germs. Baking soda NaHCO3, chemical name sodium hydrogen carbonate. It is produced using sodium chloride as one of the raw materials. NaCl plus water plus carbon dioxide plus ammonia gives ammonium chloride plus sodium hydrogen carbonate. On heating, the following reaction takes place and sodium carbonate is formed. When heating sodium hydrogen carbonate, it gives sodium carbonate plus water plus carbon dioxide. Uses of baking soda. First one, it is used as an antacid in medicine to remove acidity of the stomach and provides relief. Second, it is used in making baking powder. Baking powder is a mixture of baking soda and a mild edible tartaric acid. When baking soda mixes with water, then sodium hydrogen carbonate reacts with tartaric acid to evolve carbon dioxide gas. This gas produced in the reaction cause bread or cake to rise, making them soft and spongy. Third, it is also used in soda acid fire extinguisher. Washing soda, Na2CO3, 10 molecules of water. Recrystallization of sodium carbonate gives washing soda. Here, water molecules form an integral part of sodium carbonate crystals, which we call washing soda. Na2CO3 plus 10 molecules of water gives sodium carbonate. We will look at water of crystallization a little later in some more detail. Uses of washing soda. Sodium carbonate is used in soap industries. It is used in the manufacture of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. What is water of crystallization? Sometimes water molecules form an essential part of the crystal structure of some compounds. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. For example, 5 water molecules are present in one formula unit of copper sulfate. Chemical formula for hydrated copper sulfate is copper sulfate plus 5 molecules of water. Similarly, crystals of calcium sulfate with water molecules is called plaster of Paris. Calcium sulfate with half molecules of water, or it is also called calcium sulfate hemihydrate. Copper sulfate pentahydrate is blue in color. Uses of plaster of Paris. It is used in hospital for setting fractured bone. It is used for making toys, decoration material, cheap ornament, chalk, etc. It is used for fireproofing material. It is used for making surface smooth. Okay, children, I hope you understood the concepts in acid, bases, and salts. If you have any doubts, please let us know. See you soon in the next video, part 2. Bye.